and Q, yeah, it's one of those, it's kind of one of those things where I think you'll see soon enough, like, once you go through like the trig course, you see, because with the trig course, you're going to go through, different ways of working out, like, or solving for X rather, or even just getting the general solution. So, for example, the issue is if you see that this has a negative and this here has what it has here. Obviously, the issue is that in terms of you like, wait, this is GFX. What did I write down there? Oops. This is G of X. So this is definitely an interesting question, right? The only thing is, if you're gonna work out where these two intersect, you're gonna have f of x equal to g of x, right?
Yeah.
Is going to look like this. So the only issue is you can see that here, yeah, this has a sign over here. I mean, this has this here. Let me make it green so that it stands out. So what you may wanna do is you may wanna rewrite this side so that it doesn't have this out here. So the one thing you can make use of is how you know that sine with a negative angle is equal to negative sine that angle. Do you remember?
Yeah.
Yeah. So the first thing you can do for yourself is rewrite this like sine negative 2x equal to cos x minus 30. Now from the trigonometry course and also from recently the math paper 2 that I went through, the 2018 one, the June 2018 paper 2 memo, the trig section, we had a question like this. And the one thing I mentioned was it's actually better to usually change what you have to have cos's on both sides. The reason is, so for cos, we know that cos 90 minus an angle is equal to sine that angle, you see. So in our case here, we have sine with an angle. Let me just keep it in orange. I always change color too much. So we have sine with a negative 2x here. It's going to be the same as cos 90 minus the negative 2x. You see?
Yeah.
Meaning what we have here, right? Let's just put arrows. What we have here, we can just change it to cos 90 minus the angle. It is equal to cos x minus 30. Now the good news is, from what we know about changing stuff to both cos's, okay, just hear this out. If you're going to change these to the same trig ratio, choose cos. Always choose cos. It's the easier one to work with, because the moment you choose cos, you're going to split up your page. And then on the one side, you're going to take things the way they are here after dropping the cos's. You're going to have 90 with negative 2x here equal to x minus 30. You see, you've dropped the cos's. But then on the other side, you need to be careful. This here, where you did the whole 90 shebang, you have to put a negative outside. And then you have to carry on like that. And then make it equal to x minus 30. This is how you're going to get your two answers. For one side, you take it as it is. The other side, you make this bracket a negative. It's more like a rule of thumb. So that's why changing it to cos makes your life so much easier.
Mm-hmm.
Your life so much easier because remember, a negative angle here for cos is the same as the positive angle here for cos. You see, we know it. We know that cos with a negative angle is equal to cos with a positive angle. So that's why here we will take this as a positive and then we'll also take it as a negative, because we know these two sides of the yellow line, it's both sides are valid. You get? Does that make sense? Yeah.
Definitely.
So from there now, you'll be able to get answers for x. Like here, solving for x, you can just see here 90 plus 2x equal to x minus 30. If you move everything on the left, you're going to have 2x minus x equal to negative 30 minus 90. Of which here you're going to have x is equal to negative 120. If you look at it nicely on the image here, this being negative 120, it's obviously not accurate. See, so here this is where things like we could think to ourselves plus k 360, k is the element of integers. This is where we could maybe try and utilize something like this, and we'll use it right now to try and see what this could be. But it's not going to be straightforward. But so what I mean is, what this means is that for you to get other values of x, you would need to throw like random integers for k, like 1, 2, -1, -2. But unfortunately, the way it looks here, it doesn't look like we're gonna get anything valid. Yeah. So this one we can maybe put like a question mark there. Might as well even remove this because it's not gonna get us anything anyway. But then the other thing also with cases like that, it's always good to double check if maybe any errors were made. So let us see if any errors were made.
Levi,
Yep.
I know you said it's better to change the sin to a cos, but why don't you change the cos to a sine?
Yeah. So with a situation like that, you ending up with two answers or two cases where you work out two separate answers. When you have changed it to a sine, yeah, there is some form of, complications there. Because with this one, as we mentioned, it's a bit more direct, where we can easily say, wait a minute, as long as this is a negative and as long as this is a plus, it's still valid. So the green brackets here, we can either just take them together and have an equation, or we can make the one on the left here negative and we know we're still okay. So it's like easier to remember, easier to work with.
Okay.
Yeah. So on this side here, let's see what we're going to end up with here. We're going to have negative 90 plus the negative 2x there. And then here, we're going to have a plus times a negative gives you a negative. And then here we have x minus 30. If we bring the, what you may call, the x's to one side, we're going to have here x plus 2x negative 90 plus 30. And then from here, you can do the whole plus k360 thing already, because here you can have here 3x is equal to negative 60 plus k360 is the element of integers. The reason for doing this now is because we may end up needing to use that k here, because here if you divide both sides by 3, we need to take into account the fact that the k360 part also gets divided by 3. So this divided by 3 is going to be negative 20, and then this is plus k120, k is the element of integers. So if you look nicely now, it kind of does make sense that this is negative 20. See, because it's between the 45 here, so this could be a negative 20. So for us to get answers now, you will just need to say now things like, let k equal to 0. If k is a 0, you're going to have negative 20 equal, you're going to have negative 20 plus 0 times 120 equal to x. And then here, x is equal to negative 20. That's your first answer, you see. For the other answer, you can now look at this side and see for yourself, okay, you can see this is a 90. So this is just after a 90. Now to get that, we could say, let k equal to a 1. If k is a 1, you're going to have negative 20 plus 1 times 120 equal to
100.
x. Then you're going to have positive 100 equal to x. And yes, that is definitely valid. Because if this is 90, it's not too far-fetched to say that, okay, that is definitely 100, you see. So you can see, even though the left side did not give us something valid, because we are only constricted to negative 90 to 180, the right side has given us everything else we need, you see, which is the negative 20 and the, what you call, the negative 20 and the positive 100. You see, you can see this side would have given us other answers if you kept on looking towards the left, because if you look at how this is behaving, you can already see that this graph would tend somewhere, and then this one, it would go down somewhere. So they would meet eventually somewhere here, of which, just from what we saw on our calculations, it looks like this here would be negative 120 because of this.
Yeah.
So we just have to say that is not valid because it's not within our given domain. Cool. Yeah. So it also then goes back to knowing how to deal with these, you see. So
Yeah.
this example was pretty darn good, like proper pretty darn good. So yeah, this one is a Zopa's accord.